Thank you, Vishal. Well, I'm thrilled at this turnout and thrilled to be here at this event. I'm actually a Boston guy, so as Vishal mentioned, I was at Endeca for about 7 years, and for those of you who may not know Endeca, you have actually used Endeca's software. So if you have ever gone to HomeDepot.com or NikeStore.com and looked for anything, search or navigate by the menus, that was Endeca's software. And the problem that we were trying to solve was, how do you help people find information they need, especially when they don't know it exists? And so from a design standpoint, this is a real puzzle. It's really thinking through, how do you help people solve problems? How do you help them ask better questions? And the trick was to create a system that would tell people with real questions, with some interest in what they're looking for, what is in the data, even though they know nothing about how to query it. It turns out that this was a bigger problem than we had anticipated, and we started to see it not just in e-commerce, but we saw it inside of large organizations as well. So places like Ford, like Whirlpool, like IBM, used our software to provide easy exploration across a big variety of data inside these large companies. What we were really doing was helping regular people use big data before it had a name. Our focus was on big variety. When you have a whole bunch of different kinds of data, different structures, some of it's structured, some of it's unstructured, whatever. And you have to help people who have expertise in something or other, but no ability to write queries, understand what's in the data so they can ask better questions. So we ended up getting bought by Oracle, which, if you're on the East Coast, is a standard rite of passage. So if you have not had your acquisition experience yet, you can look forward to your acquisition experience. It will happen at some point. But what turns out, inside of Oracle, the big data problem is a huge deal. From the vantage point of Oracle, you can actually see inside of Exxon, Chevron, Airbus, Boeing, and find out globally the big data market is developing at pretty much the same rate worldwide. So what we're going to talk about here is a little bit about what big data is and what it does, but mostly about what it means. And really how to get started building a big data strategy. So let's begin at the beginning. We need to understand what big data is. And I don't know about you, but my experience has been that if you get 5, let's say, CIOs in a room, you get 8 opinions on what big data is. Everybody's heard of it. They all believe there's some promise there, but it's still really mysterious. So let me just take all the mystery out of it here at the beginning. And I will tell you first what big data is not. So big data is not a specific technology. It is not a specific solution, not even one from Oracle. It is not even a special kind of data. Big data is a phenomenon. And the phenomenon is the datafication of everything, the capture and the use of more data in more daily activities. That's it. That's the whole shooting match. No mystery about what big data is. It is the capture and use of more data in more daily activities. But we need to, dispel some of the questions about, well, what can you do with it? How do you get started with it? And to do that, we actually need to go backwards a little bit. We need to go back to a time when there was a technology that was equally mysterious that later turned out to be a big deal. So any of you who are English majors or history majors know, in 1752, Benjamin Franklin went out on a hot and humid night into a field outside of Philadelphia, and he flew a kite in a lightning storm. So if you don't know this story, what he did was he tied a metal wire to the top of the kite, brass key to the bottom of the string, and then in the middle of the lightning storm, when the fibers on the string started to stiffen, he reached his knuckles out and drew sparks off of this key. He didn't grab the thing because one time in his lab he knocked himself unconscious with electricity. True story. But then he actually captured lightning in a bottle. He took an early battery, it was called a Leyden jar, trapped some of the sparks coming off of the key, took it back to the lab, and proved it was the same stuff that he generated in the lab. So what? The so what is that Franklin was not merely curious. He was trying to solve a problem. And the problem was lightning strikes. And so he had to find out more about this mysterious fluid, how it moves, where it comes from, and what you can do to control it. That summer, the first lightning rods were set up in Philadelphia because he had demonstrated that lightning in the sky was the same as the electricity in the lab, and he knew how to conduct it away. Okay, so this is the beginning, and then what happens over time is that many inventors came along and turned this mysterious fluid, this substance, into one of the most useful substances, most useful powers mankind had ever seen. New products, new services, new ways of working and thinking. And that is where we are right now. Right now, we're at the same pivotal moment with big data. Big data is a mysterious fluid that flows through everything. It is a new kind of power that changes everything that it touches. And you know this because you are already part of the datafication of everything. So, we already know that Facebook users datafy their thoughts and opinions. Twitter users datafy their thoughts and opinions about AnalyticsWeek. So Twitter processes about 500 million tweets a day, which is nothing. Facebook users share about 500 million pieces of content with each other every 60 seconds, every minute. And so those thoughts and opinions that you used to have that would disappear into the ether, now they're captured as data, and they can be used to inform marketing campaigns, the next generation of product design. They completely change the way that movies are marketed. Fast and Furious 5 did an entirely new thing with the way they spent their advertising dollars last summer because of the datafication of thoughts and opinions. But then there's the datafication of things. So with the datafication of things, we're starting to see, things like the state of Michigan tags cows at birth. Every single cow born in the state of Michigan is tagged at birth, producing a lifetime of data. And that helps them to respond more quickly to disease outbreaks. Entire buildings are instrumented not only with security cameras, but with humidity sensors, temperature sensors, seismic sensors that help to reduce the cost of maintaining those buildings while maintaining them at higher quality and higher safety. So this is the datafication of things. We're at the very beginning of that. But we also see the datafication of activities. Now, if you have worked in IT or in software for a while, you know that this has been the story in large organizations. Putting in enterprise resource planning software, CRM software. It's the datafication of activities in large organizations. But what's happening now is the datafication of ever smaller and smaller activities. How many people here have funded a project on Kickstarter or Indiegogo? So I would say it looks like about a quarter of the room. So about a quarter of the room has funded something on Kickstarter or Indiegogo. If you don't know these platforms, Kickstarter is a great example. It's a platform for raising small amounts of money, like $50,000 or something like that, to fund a dream project. Telephoto lenses for an iPhone, or the perfect pair of cycling commuting jeans. Kickstarter has now raised over $1 billion across 57,000 projects. So that's interesting. But a couple of researchers took the data about the funding of those projects. And they took the data about how much money comes in at what rate for different kinds of projects. And then they combined that with the Twitter data to look at who was talking about the projects and promoting them. With that, they created an algorithm that can predict the successful funding of a project within 4 hours. Within 4 hours, this algorithm will predict with over 80% accuracy whether that project will meet its funding target or not. So just think about this as one example of the datafication of everything. It used to be that the raising of money would produce just analog information, but now it is captured digitally. That data can then be fed into an algorithm. It can be used in a completely different way to predict the likelihood of that project being fully funded. This is a small example of what is happening millions and millions and millions and millions of times over across the real economy. The datafication of everything is like a kind of electricity that now courses through all that we do. And it opens the possibility for creating new products, new services, new ways of working. And that's great. So what's the problem? Well, the problem is that the world's ability to produce data has dramatically outstripped most organizations' ability to use it. And so at Oracle, we did a survey with the sister company of The Economist Intelligence Unit, and we found out that only 12% of executives feel they understand what data will mean to their organizations over the next 3 years. So this is like going back to 1890 and asking executives who run steel companies, who run railroads, what will electricity mean to your business? And only 12% of them feel like they have a grip on it. That's where we are right now. And so this raises a new question. And the new question is, how do you make big data useful? How do you close this gap? Now, for a lot of startups out there, their very being, their very reason for starting up in the first place is because they have a grand new idea about how to close this gap. But there is an entire global economy out there full of large governments, large organizations, large businesses who have already invested hundreds of millions of dollars each, if not more, into analytical technology. And they are asking, how do we bring big data into the enterprise analytical environment and make it useful? How do we bring big data into the real economy and make it useful? And to answer that, we need to take a look at the effect that big data will have on the analytical environment that's already there, as well as the new opportunities that big data opens up. So let's start with what's already there. So all organizations already have some kind of data warehouse, some kind of data mart. They have business intelligence platforms. They have dashboards. They have reports that give them key performance indicators and great metrics. Thanks. And so this is the world of the relational database, which Oracle knows well and loves. Some people do, some other people do as well. But this world is one that is based on a very simple idea. Build the model first, and then fill it with conforming data. So in the relational world, in the world of the relational database, you have this incredible power to standardize and control data so that you can standardize and control business processes. Like that. And this is the world that you use to run the business. Okay, so what's going to happen here? Well, with big data, what's going to happen here is that the data warehouse is going to get taller. It will have more rows of the same stuff, a greater volume of data. To handle that, big retailers, big insurance companies, big oil companies, they're all going to need more processing power at lower total cost of ownership. This is a familiar problem with a familiar solution. So this is a problem that the technology industry has solved many times. This is a problem that technology buyers have solved many times. It is not exotic. And it's going to happen again in a world that is fully datafied. But this time, there is something else. And the something else is what happens with the datafication of everything. With the datafication of everything, you don't just get a greater volume of data, you get a greater variety of data. That's the big story. And this whole talk about structured versus unstructured, it's a red herring. The issue is diversity of the data. The issue is that tweets have got 33 meta tags on them. And not a single one of the big brand advertisers decided what they would be. And not a single one of the big brand advertisers has the power to say they should stay the same. So we live now in this world where there is more data born about a company's products, customers, its own processes, outside its four walls than inside. And that means that these companies have to figure out how to bring in this great diversity of data and make it useful before it's organized into a nice, neat model. And this is the opportunity in the world of non-relational analytical technology. This is where Hadoop is such a big deal. This is where NoSQL is such a big deal. This is where discovery technologies like Endeca are such a big deal, because it represents the opportunity to learn from the data before it's organized into a nice, neat model so that you can change the way the business functions. So that you can change the way that you interact with customers, you can actually change the way that you reach them. Perhaps you can even change the next generation of your own product. Now, these two worlds are not substitutes for each other. They live next door to each other. So every large organization, frankly, even small ones, are going to end up with some kind of run the business analytical environment, some kind of change the business analytical environment. The fundamental difference between them is that the run the business environment is where you organize the data to make it do something specific. The change the business environment is where you take the data as is to figure out what it can do. It is the difference between model first and data first, relational and non-relational. And the two together are more powerful than either alone. One, the model-first world cuts the cost of standardizing and controlling data to standardize and control processes. The other, the data-first world, cuts the cost of experimenting and exploring a great variety of data before you know exactly what it can do for you. But the real key is to get them to work together. And this has actually happened before. So in the early days of electricity, there was a standards war, a bitter standards war. The AC guys versus the DC guys. And it gave us a great band. That's terrific. But it was a bitter fight at the time. And it involved, I kid you not, some of these guys electrocuting animals in order to prove that the other guy's approach to electricity was too dangerous to be allowed into the market. True, awful story. What ended up happening was that we got both. We got AC and DC. AC is what runs through the high tension wires that crisscross this country. AC is what comes out of the wall. And DC is what's in the battery that is in the heart of every single mobile device. Every single one of us, every day, uses both. We benefit from DC during the day, and then we plug it into AC at night. And if you take away either, the world is poorer for it. The two together are more powerful than either alone. And it's the same thing. It is the same thing with the kinds of analytics and analytical environments that organizations need in order to make big data useful. Okay. So to do this, to bring big data into the enterprise and make it useful, you need some gear. You need some technology. You have to have relational databases that process transactions, but they won't live alone. They'll be next to NoSQL databases that process web interactions or interactions from devices. You still need that data warehouse in order to crank out these standardized reports, but you're going to also have to have Hadoop clusters to keep a greater variety of data on hand, even though you're not exactly sure what you're going to do with it yet. And you're still going to have BI with reports, and that's going to be complemented by data discovery. All of this stuff has to seamlessly work together. But I have good news. Oracle can help. So you know I'm going to say that. Oracle has some great technology. You should check it out. But that's not the point. The point is, what would it mean? What would it mean if you actually had these two worlds working together, relational and non-relational technologies seamlessly deployed together to try to make big data useful in an enterprise? Well, what it would mean is new capabilities. And these are the four that we focus on. The first is getting fast answers to new questions. This is about discovery. This is the thing that Endeca was really focused on. So one of the companies that we worked with is a company called Delphi. Delphi is a tier 1 auto supplier. They make airbags, they make radios that go into all the cars that we drive. At any point in time, they have 340,000 active parts in millions of vehicles worldwide. The issue they face is warranty claims. because the manufacturers, like Ford, like Toyota, like GM, hand warranty claims to Delphi. And Delphi is contractually obligated to pay those claims within 30 days unless they can prove they're not responsible. Now, the thing that makes this difficult with warranty claims is that each warranty investigation is unique. When you find out what may have been going wrong with the explosive bolts on an airbag, it tells you nothing about what may be going on with malfunctioning windshield wipers. In addition, each one of these unique investigations relies on a huge variety of data. So Delphi alone has data from their trouble ticket system, where they're actually getting calls from technicians who are trying to fix things. They have data from their remanufacturing system, where they take in radios and other devices that have been returned to them, and they work on them, finding out what went wrong with them in the real world. They have data from their supplier system, which is separate, incredibly, from data about the parts they buy from those suppliers. They also have data from these warranty claims that are filled with long-form text. There's no inherent structure there at all. And it's filled with bad grammar and misspellings, just the language of the world. In addition, they also need the data from the manufacturers themselves, which have this problem of a great variety of structures, which Delphi does not control, and which the manufacturers change whenever they feel like it. So Delphi had this problem, a big variety. They don't know what questions they're going to have to ask, and so what do you do? This is where the data-first approach makes such a difference. If you don't know what questions you're going to ask, and you don't know what data is going to be most valuable to you, you can't build a model. So the model-first approach won't work for you. You need a data-first approach. And so this is what Delphi did, and the system paid for itself within 30 days because they found that they weren't responsible for a particular set of claims that they'd been handed. But that wasn't the big prize. The big prize was the realization that because they could get fast answers to new questions, easy exploration across a great variety of data, they could have a unique warranty strategy for each of the 10,000 parts in the electronics safety division. If they can do that, then they can provide a higher level of service to the manufacturers so that they can actually make the cars that all of we buy safer. So this idea of the data-first approach to big variety is critical to making big data useful inside a large organization. The second kind of business value that we find is predict more and more accurately. This is about predictive analytics. And I'll tell you the dirty little secret about predictive analytics. Predictive analytics, except perhaps in the hands of Nate Silver, do not predict big things. Predictive analytics predicts small things, millions and millions of times over. And so companies like Dell, for example, captures an enormous amount of data from interactions at the website, but also interactions in their call center. They capture data from email campaigns. They capture data from the responses to their print campaigns. And they keep it all in a great big Hadoop cluster, great big data farm. But then they want to use that data to inform offers on the website, to recommend best next action to the call center reps, even to make predictions about which creative will be most effective on their print campaigns, because they do something they call on-demand print. And so they use this thing called real-time decisions. That's a machine learning algorithm that takes in a great variety of data, uses that variety of data to make predictions about next best action and pricing and so on and so forth. And then when the performance of those predictions falls, it changes its own behavior to try to bring that prediction back up. The third kind of value that we see is create a data reservoir. And this is one that really is new in the world of big data. There is a book that I highly recommend on big data, and it's called, appropriately enough, Big Data. A revolution in how we work, live, and play, or something like that. It's by Ken Cukier, C-U-K-I-E-R, and he is the data editor at The Economist. The reason the book is so good is because he and his co-author are not technologists. They could not care less what the technology underneath is. They're thinking rather about the use of information in business and society and how it changes in a world of the datafication of everything. One of the things that changes in a fully datafied world is something called the option value of data. This is their term. The option value of data is when you can use data you collected for one thing to solve a completely different problem, one that you did not know you would be able to tackle when you collected the stuff in the first place. And so we have an example of this. We worked with a large bank, has many, many regional offices, and it has a new problem. The new problem is the regulators have given the bank a new liquidity test, a new test to see if their capitalization is sufficient to the money they have on deposit. And the data they need is scattered across all of their branch offices. And some of it's in warehouses, and some of it's in databases, some of it's in mainframes. And it's kind of connected with this very brittle point-to-point integration system, and it keeps falling apart. So what they did instead was brought all this great variety of data into a big Hadoop cluster. And it sits on a piece of Oracle hardware, but it brings it into this Hadoop cluster because Hadoop does not require a model first. It's just a big file system. So you can pour any kind of data in there you want, regardless of its original structure. You pour it in there as is. So they have this great big reservoir of data, and then they take an extract out of that and put it into this data warehouse that then runs the test because it has a nice model. Okay, so that's good. They solved the problem they were trying to solve. But then the marketing department found out that the CFO created this reservoir and said, now we can do this cross-geography, cross-product customer profitability analysis that we've always wanted to do that we couldn't do before. This was a completely new problem that could be solved by the same reservoir. It is the option value of that data. Now, one of the things that I hear a lot when we talk about this idea is that this is stupid. And the main justification for this being stupid is, how can you tell me that I should pay to keep more data on hand when I don't know what it's going to do for me? That is dumb. One of the reasons that companies are doing this anyway is because the cost of doing this has fallen so low with the advent of Hadoop. The other reason is that their competitors are already doing it because innovative companies believe in this option value. Orbitz had this kind of famous story where they created a database they called EFX, which they claim stands for every freaking X. It may be freaking, it may not be. Every freaking X, 150 attributes on every single person who comes to their website, and they had no idea what they would do with it. Now, some of you may remember the story that one of the things they did with it is they started recommending hotel rooms to Mac users, which were $30 a night above the average, because Mac users apparently have extra money to burn. Turns out it's true. But they did not know what they would be able to do with that data when they started to collect it. 150 terabytes of the stuff. So that's the third kind of value. The fourth one is data-driven, accelerating data-driven action. This really is about taking action in real time on data, especially a great variety of data. A lot of the stuff that we've talked about so far is data for people. It's making easy exploration of big variety. That's data for people. This is data for machines. So here we're talking about algorithms that use a great variety of data in order to take action on your behalf. This is something that's going to be big in the Internet of Things, in the machine-to-machine world. Just one example I'll give you is another large bank we worked with, where they had a new idea. They thought that they could take their transaction data, combine it with the geography data they get from people making withdrawals and deposits at ATMs, and turn that into a service for retailers to target ads to people's phones in real time as they walk past the shop. It works. This is live in production in Spain. This is an entirely new service from this bank. And it depends on a great variety of data, some of it coming from relational sources, some of it non-relational, being piped through an analytical system that involves both data warehouses and Hadoop clusters, going through predictive algorithms in this case, to then send ads directly to users in real time. So these are the kinds of things that we talk about, the kinds of things that we think about when we talk about big data at work, when we talk about the relational and non-relational analytical environments. seamlessly working together. But let me leave you with just 3 things on getting started with these ideas. 3 things on getting started on a big data strategy. So the first idea in building your big data strategy is that you need to think in terms of data market share. So a lot of us can think in terms of market share around customers, for example. We know that there are so many males between 25 and 34 and spend a lot of money on video games, and so we want to know, as a video game producer, how many of those customers, how many of those people do we have? That's a familiar concept. Thinking in terms of data market share means that you are thinking in terms of data generating activities. That's where data comes from. Data comes from activity. Activity in personal, public, and commercial life. And the key is to grab, like in a land grab, data generating activities. And so you need to think beyond the activities that beyond the interactions you have with your customers, beyond the activities that you conduct within your four walls. Start thinking about activities that your customers have with other providers in your industry. Start thinking about activities that you conduct among suppliers or that they conduct among themselves. And think about whether or not you can introduce a computer in there, a mobile app. Maybe it's even just a new web app. Or maybe it's creating some new device that captures data from the outside world. So there's a land grab here, because not all data generating activities create data of equal value. And while there is the option value, so you can't always be sure exactly what you can do with all this data, it turns out that once a rival gets a majority share of the activity that produces that valuable data, it's really, really hard to catch them. So start thinking about data generating activities in your extended value chain. The second idea is to create proprietary data assets. Now, this is a little bit tricky. If you remember, I mentioned that more data is created outside the 4 walls of a company than inside. More data about that company's products, customers, processes. Well, if it's created outside the company, then it's available to the company's rivals too. So now what? How do you make it proprietary? Well, it turns out that when you bring data that is available to your rivals as well, in-house, let's say it's Twitter tweets that mention your products or that mention your restaurant chain. Your rivals can buy those too. But when you bring them inside and combine them with data only you have, proprietary data about customers, proprietary data about locations, about facilities, about your own transactions and the kind of discounts you have, it's like pouring milk into a cup of coffee. It changes the whole drink. It makes that whole asset proprietary, giving you a unique view on the market that only you can see. This is the second idea. The third, the final idea that I'll give you about creating a data strategy is use data to make data. So remember, I mentioned that you need to think in terms of data market share. Once you have a majority of the interactions that generate this valuable data, the real magic is to then use that data to refine the services you deliver or the products that you make in order to claim an even greater share of that data generating activity. This is exactly what Google does. So Google uses all of the data generated about how we respond to the search results we see, what we click on and what we don't click on, in order to improve the results for the next user who searches on that term. This creates a big data flywheel. And that is a competitive advantage that is extraordinarily difficult to catch. So these are the main planks of creating a big data strategy. And the reason this is such a big deal now is because we're at this pivotal point, like back in the early days of electricity. In 1893, at the Chicago World's Fair, there was a huge white building lit up with 200,000 incandescent bulbs. No one had ever seen anything like it. So you have to picture this. In 1893, at home, if your streets are lit at all, they're probably lit by gas. And then you go to the World's Fair. And this building with 200,000 incandescent bulbs lights up the night sky like the noonday sun. It's amazing. But outside the fair, the world is mostly dark. And that's where we are now. For all of the big data bright spots that we've talked about here, that you're familiar with, the world is mostly dark. And it waits. It waits for what you will create, the new products, the new services, the new ways of working that you will create with this newly abundant resource. And being here is part of the first step. Thanks very much. Vishal?
Any questions? For Bob? Yes.
So you mentioned this whole presentation creating
Sure. So in terms of creating public good, one of the places that we see this happening is in healthcare, and this is one of, this is like the mother of all big data problems, because when you think about increasing medical outcomes relative to costs, part of the challenge is to see all of the care providers around a person, with perhaps many conditions, being treated in the hospital, out of the hospital, at home. And sometimes, really you need to know what's going on at home in order to reduce readmission rates at the hospital. So this is one of the places where new combinations of a big variety of data really make a difference. One of the other kinds of things that we see are just great experiments. Like here in Boston, there is a fabulous Adopt a Fire Hydrant program. Has anybody adopted a fire hydrant in Boston? Okay, so ask Bill Oates about this when you see him. So you can adopt a fire hydrant in Boston, and that means that when it snows, you go and dig it out. And then you take a picture of it. And you send it in using the mobile app to prove that you have in fact dug out your adopted fire hydrant. Well, the net effect of this is basically, higher quality services in the sense that these fire hydrants, they're dug out quickly after the storm, but at lower overall cost to the city. So this really is a way that technology reduces the transaction costs of coordinating volunteer activity in a large urban area. So this is one of the other ways that we see that happening. Yes? Sure. So the question is about cost, about and how to begin. So there are lots of different ways to get started, but you don't have to pull out your checkbook in order to get started. So one way to get started is that you can use a lot of cloud-based services in order to capture data, hold it. Even there are open source tools like R, the statistical programming package. And frankly, one of the things that is really, really in short supply is good thinking about data. One of the things that's really in short supply is how to think with data and to think with math in order to better understand the world and come to some conclusions about it. So you don't have to, as a small company, you don't have to start shelling out huge money. I will tell you that with large organizations, they do have this problem that they already work at an enormous scale, a gigantic scale. And so when introducing this new analytical environment that I talked about, this non-relational world, it has all kinds of requirements, like it has to be completely secure. It has to do backups. It has to be consistent with disaster recovery. It has to be consistent with auditing so that if you're a life sciences firm, you can demonstrate that the data you have about your clinical trials in that Hadoop cluster was only accessed by people who have appropriate rights to see it. So in large organizations, there are large startup costs in getting started with big data. But if you're a small company, man, the most valuable thing is a great idea. So I'll still be around. I can answer more questions, but I imagine you want to get to the break.
So we'll have a 30-minute networking break, and I think they are setting up the food stands. So meet you in 30 minutes. Thank you, guys. Thanks, Paul. Thank you so much.